this session, we are going to describe how inter-VLAN forwarding works with VXLAN. We are going to include inter-VLAN forwarding with multicast as the control plane and inter-VLAN forwarding using layer 3 VNIs. We are going to describe the first case where we are using multicast as the data plane. The case is the following: hosts live in different VLANs and are connected to different switches. In order to reach each other, now we are going to need the file gateways. Addressing belongs to the same VRF. Now the first step in order to make this inter-VLAN forwarding work is creating our layer 2 VNIs mapping. So we are going to create all VLANs at all VTEPs with their corresponding layer 2 VNI mapping. So at this VTEP we are going to create VLAN 10 and 20. At this VTEP we are going to create VLAN 10 and 20, and we are going to map them to their corresponding layer 2 VNIs. We are going to use the same mappings at both devices. Now we need to create our default gateway. So we are going to create SVIs for each VLAN. So we are going to create SVI 10 and SVI 20 at each VTEP. Notice that we are going to use the same IP addressing, for instance, the same IP address for SVI 20 at each device, the same IP address for SVI 10 at each device. This feature is known as Anycast gateway, in such a way that all the hosts that are connected to this X switch believe that their default gateway lives in this switch, and all the hosts that are connected to Y switch believe that their default gateway lives within this switch. Now the process is the following: host A wants to send a packet to host B. Host B lives in a different VLAN in a different device. So VTEP X receives the frame. This frame is originally received within VLAN 10. Then VTEP X is going to perform layer 3 forwarding between both VLANs because it contains both SVIs. So after doing that, the frame now lives in VLAN 20 and it needs to be sent to the destination VTEP. So the VTEP X needs to forward this frame, but this frame lives inside the destination VLAN 20. So after this point, the process is the same as a regular layer 2 forwarding. We are going to build this encapsulation. Notice that the destination IP is actually the IP of the destination VTEP. The source IP belongs to the ID of the sending VTEP, and the VXLAN ID is actually the mapping for VLAN 20. So we are going to transport this encapsulation. This is regular layer 2 forwarding. As the receiving VTEP receives this packet, it is going to notice that this frame belongs to VLAN 20 and it is going to deliver it to the end host. Let's review another way to do the same. We are going to perform layer 3 forwarding, inter-VLAN forwarding, but now we are going to use layer 3 VNIs. We are going to assume we are not using multicast as the control plane. We are using another protocol. So the scenario is the same. We have hosts that live in different VLANs in different devices. In order to reach each other, we are going to need default gateways, and all of this addressing belongs to the same VRF. As in the previous case, we will need to set up our default gateways. We are going to create SVIs for each VLAN. We are going to create SVI 10 and SVI 20 at each VTEP. Notice that we are repeating the IP addresses. This is known as Anycast gateway. And so in such a way that hosts that are connected to this particular switch X believe that all their default gateways live within switch X, and all hosts that are connected to this switch Y will believe that their default gateways live in switch Y. Now it comes the interesting part. We are going to create a layer 3 VNI. In order to do so, we are going to choose a particular VNI number. Let's say that we are going to choose 30, 30, 30. First, we are going to relate this VNI with a VRF. Then we are going to create a dummy VLAN. In this case, let's say VLAN 30, and we are going to map this VNI to VLAN 30. We are going to create an SVI for this VLAN. This will become our layer 3 VNI. We are going to repeat this process at each VTIP. So this is known as symmetric integrated routing and bridging, because we are going to have the same configuration at each VTIP. Now, the process that it is going to be followed in order to send this packet coming from device A to device V that lives in a different VLAN in a different device is the following. Device A is going to send a frame to VTIP X. VTIP X is going to receive this frame. It is going to perform a MAC to VRF lookup and then an IP to VRF lookup. It is going to reach the conclusion that it needs to forward this packet. The control plane is going to provide the destination IP address, that is the IP address of the destination VTIP. The source IP address is the IP that identifies the source VTIP, and the VXLAN ID that is going to be included in this encapsulation will be the layer 3 VNI. So this particular frame belongs to the user's VRF. This packet is going to be transported by the layer 3 core, and once this packet reaches the destination VTIP, the VTIP is going to perform the opposite process. It is going to look this packet within an IP to VRF table, and then within a MAC to VRF table, and it is going to reach the conclusion that it needs to encapsulate the frame and deliver it to host B. This is a summary of what we saw in this session. We talked about what is the process for inter-VLAN forwarding using multicast. In this case, the source VTIP is going to perform most of the work. It is going to receive the frame that belongs to VLAN 10. In this example, it is going to perform inter-VLAN forwarding to VLAN 20, and it is going to forward this packet to the destination VTIP using regular layer 2 forwarding. In this case, it is going to use a layer 2 VNI that correspond to VLAN 20. We also describe how the inter-VLAN forwarding works with layer 3 VNIs. In this case, we talk about the symmetric example that is known as symmetric integrated routing and bridging for VXLAN. In this case, the source VTIP is going to perform two lookups, a MAC to VRF lookup, then an IP to VRF lookup. Then it is going to forward this frame using a layer 3 VNI. In this case, this is the VNI that identifies the VRF, and then the destination VTIP is going to perform the opposite process. It is going to perform an IP to VRF lookup, then a MAC to VRF lookup, and then it is going to reach the conclusion that it needs to deliver this frame to a host that is connected to it. That's it.